Hello, everyone, and welcome to the Present Your Thesis, Dissertation, or Research event. Today, we're sharing the presentation of Santiago Ortiz. So because of some technical difficulties in the live event for Santiago's presentation, this recording only includes his presentation and does not include the Q&A and feedback session that previously occurred during the live event. So, introducing our presenter today, Santiago Ortiz is a historian, a master in GIS, and a self-taught programmer. He recently completed a master's degree in geomatics at the Polytechnical University of Valencia. He has a multidisciplinary interest in combining methods and methodologies from different knowledge fields, such as linguistics and history, geomatics and heritage, or humanities and technology. He's passionate about drones, 3D modeling, and architectonic heritage. In the live event, we had expert feedback from two CIPA experts and executive members. So we had technical expertise from Dimitrios Skarlatos, a professor in the Department of Civil Engineering and Geomatics in Cyprus University of Technology. He specializes in the documentation of cultural heritage and underwater photogrammetry. We also had technical expertise feedback from Stratos Stylianidis, who is affiliated with the School of Spatial Planning and Development in the Faculty of Engineering at Aristotle University of Thessaloniki in Greece. His research interests focus on geoinformatics and geospatial engineering with applications in both the natural and built environment. So today, Santiago is going to be presenting his master's research titled Comparative Digital Reconstruction Using Photogrammetry and Low-Cost Methodologies, Heritage Documentation at the Siecha Chapel as a Contribution to the Formation of a Digital Collection of Colombian Architectural Heritage. So thank you so much, Santiago, for being here today, and please go ahead with your presentation.
Thank you for the presentation. It's a pleasure for me to present my research. We'll start now. Can you see my slide?
Yep.
Okay, my title presentations is Comparative Digital Reconstruction Using Photogrammetry and Low-Cost Methodologies. The study case of Siecha Chapel in Colombia. Okay. The main goals of my research are five main goals. The first one is to carry out a comprehensive and interdisciplinary state-of-the-art on architectural heritage documentation, to carry out a holistic heritage documentation project that includes the greatest possible diversity inputs. Third one is to compare the workflows from start to end and the results obtained from proprietary and open source photogrammetry tools. To access the requirements, strengths, and limitations of each photogrammetry workflow from a complex accessibility point of view. And the last one is to explore dissemination solutions for generated products. Now, some context of the research and the building, the historic building. Well, during the previous decades, the chapel was a symbol of resistance, first for the indigenous community as a memory place of colonial times, and also was a meme against open sky mining in the area. Nowadays, the community takes care of heritage building because they see social, historical, spiritual, aesthetic, and symbolic value represented by it. The CHS community may actually gather in a formal association called Siecha that won a legal dispute for the land use by achieving a legal disposition to declare the chapel a national monument of public interest and stopping any mining activity in the area. Were to say that my project with the chapel began as a personal academic research, but now the community have reached me and demonstrated deep interest to articulate this documentation effort with their attempt to find public and private resources for a partial restoration of the building, to plant some trees, and to plan the construction of a visitor area. Mm, well, holistic documentation. Um, the importance of an holistic document approach is to enrich the geometric modeling as much as possible, starting from collecting all related information for multi-level documentation. Mm, of course, it needs different types of skills and perspectives. If possible, different kinds of experts. The principal aim here is to methodologically integrate sources of different natures, such as historical cartography, interviews, imagery, measurements, direct measurements, to integrate it at different stages of the process. The potential result could be an H-beam or many different products, such as online viewers with many related layers, such as cartography, videography, images, animations, 3D prints, 3D models with metadata, so on. Hopefully, generating new knowledge. The theoretical framework of this research. First, the heritage value is a concept that I used along the whole research. And the heritage value is composed of social, historical, spiritual, symbologic, aesthetical, and academical value. Another concept that I used mainly to point out the end, the final end, the final great objective of the research is to benefit the heritage community that was defined in 2005, that in these terms, that consist of people who value specific aspects of cultural heritage, which they wish, within the framework of public action, to sustain and transmit to future generations. Also, another conceptual framework here integrated with this approach of heritage the community is the low cost. So I define low cost as anything that embrace only the operational expenses, including devices and software, and excluding expert fees. Within this frame, photogrammetry is the best cost-effective, is the golden rule until today. For geometrical reconstruction, for geometric reconstruction, but it has some limitations, of course. So low cost is always in comparison to high-end equipment, like other techniques, like laser grammetry and all that. Why to propose a low-cost approach? Because there are many monuments and historical sites that aren't famous or aren't getting any attention, and therefore they are not being documented, but are still relevant in several levels, and their communities and humanity as a whole can benefit of getting knowledge of these historical sites. Well. The sensors and platforms that I used, well, I took 40,435 photos, 11 ground points with a handheld GPS. Also, I took 6 measured distances for scaling and later process. I actually used two drones, well, two drones of the same model, and a third one of a latest, more advanced drone. In manual flights, the drones I'd use were Phantom 4 Pro and Mavic 3 Enterprise. Notice that all of them use a camera with a mechanical shooter, ideal for photogrammetry. I flow them in manual mode in the interior for the internal heights, and in the for the exterior to achieve to reach all these problematic areas. Also, in general, the of the building. The total operational cost I calculated, including the drones, the camera, the GPS, and the hardware used to process, in $8,650 approximate. This was only for sensors, platforms, and processing machine. Okay. The general life cycle of 3D model generation. This flowchart represents this holistic approach that I proposed. This is an end-to-end methodology for documenting heritage sites. It illustrates how raw spatial and historical data are transformed into valuable assets for community and researchers. The first two phases are preparation and collection, and is the foundation of this schema. Different types of data are gathered, spatial and non-spatial data, like interviews, all the imagery, the measurements, also the preparation, the planning, everything. This could be the most more important phases. Later on, the phases 3 and 4, the processing stages. This is the technical engine of the workflow. Raw inputs are carefully managed, photogrammetry is processed, and tools are used to produce a clean model. And finally, the fifth and sixth phases, the output and their impact, the diffusion of the knowledge. In these phases, the raw technical models are translated into accessible formats like educational visualizations, immersive experiences, and HBM. Crucially, the final step ensures this knowledge is returned to public institutions and to the local community, the heritage community. Note that there are cross connections and iteration loops between the phases, so this is not a straight line workflow, and it's interdisciplinary validation and feedback constantly. The general tools from both workflows that I perform in my research are these that you can see listed here. Raw therapy for image development and downsampling the images to make them manageable. Also to make the process more efficient without compromising much the final quality. Cloud Compare for point cloud cleaning and model alignment, Mesh Lab for model sanitation of the topology and example, Blender to model holes filling, realistic visualizations, architectural animations, and VR. 3D Hub for to serve like a online viewer platform, DaVinci Resolve for media editing, QGIS for GIS and cartography, NetFab for the 3D printing. The specific tools of each of the two main workflows are Agisoft Metashift Pro, that is a proprietary closed source software It is characterized by its intuitive workflow and user interface and moderate parametric workflow. The other one is Measrum. It is free and open source, and it is another. It has another architecture and it is highly parametric. So let's begin with the Measrum that is developed on Elyse Vision framework. The version is 2025, and you can see here the basic nodal tree that I used. Uh, it is composed by 7 structure from motion sub-pipelines that calculates the intrinsics and the extrinsics of each image group that I separated by sensor and also by architectural component. This approach is known as augmented reconstruction. So broadly, I used 4 fundamental nodes with 40 modified parameters out of 62 available. So it is deeply customized. It is a deeply customized workflow to get a decent or good reconstruction. It also uses 6 multi-view stereo pipelines to generate depth maps and to generate the point clouds. The benefits of this highly parametric open source software is first, it is free and economically accessible. Also, great flexibility for experimentation because it's highly parametric. It offers deep understanding and control of each step. And also, it allows to develop custom nodes, custom features to create new features in the workflow. So here in this research, I developed one node to discard points from the sparse point cloud based on selected photos that may obstruct the deep maps computation. This saved me several days of expensive reprocess. So it is very convenient to develop with the Measrum. Caveats, it has a highly technical level of entrance, pure documentation and a small community that is an inconvenient. Requires powerful hardware for affordable times, and for manual editing, it needs third-party tools like MeshLab or Cloud Compare or Blender. Scanning this QR code, you can experience the 360 immersive output that I generated comparing both workflows, Measrum and Metashape. Okay, this is the final output, the geometric model generated with Measrum. Here I used 3 different descriptors. I used Akasi, DPSIF, and ZIP. And you can see that is very well reconstructed with some artifacts on the surfaces. Or to say that this chapel was very complex because of the white textureless surfaces. So I think Measrum achieved a very good model. It also had some issues with the textures for the interior mostly. And this can be related with DV maps or normal maps, generating small regions of black color. But in general, Measure achieved a remarkable output, achieving the reconstruction of a whole building accurately. Okay, let's see the other main and big tool that I used, that is Edges of Metasheet Pro. It has a convenient way to align thousands of images at once in a single chunk. So at first, I tried to align and to process different chunks, discriminating by sensors like I did with Measure, but I realized that this software is highly optimized with such cases. So in just one chunk, we can process different sensor images, and it is very powerful. It has also all other powerful tools like filter by confidence, generate reports, create masks, and insert manual markers. These tools are great. They allow you to filter the model, also to get deep insights about the quality of the reconstruction, the images, and also, well, it is it's a very professional tool. Also, it requires less control and expert knowledge for decent and good results. Some benefits of this tool is a low to medium technical level of entrance, allow easy manual intervention for point cloud filtering, images selection, marker insertion, and basic editing. It is also effective georeferencing and texturing. It has almost no issue with the texturing, even with this complex geometry. It is efficient with respect to measure, as we'll see in the next slide. Caveats, it is a paid software and closed source. Also, the access to intermediate data such as depth maps, raw sparse point cloud, and deep parameter is very limited or not accessible at all. As you can see here, the final output, the texture model, is it has very high quality, almost no artifacts whatsoever. And compared to the measure output, is much more perfect in the precise and accurate with the geometry reconstruction. The comparison of an evaluation of the outputs. First of all, the time Metashape was faster than Measure with the same data and hardware used for this research. 3 gigabytes of RAM, GTX 1650, and medium performance processor. The first criteria that I used for evaluation was how many images were successfully aligned. Measure aligned almost 4,000 photographs. Metashape, all of them, just one unaligned image. Then, well, worth to say that most demanding steps of both workflows were initial alignment, depth maps, and texturing computation for both tools. So for evaluation, the cloud-to-cloud distance algorithm, all of these within Cloud Compare. Well, the cloud of Metashape was much more denser than the one from Measure. So this impacts the evaluation indexes. But well, having this in mind, we can get some conclusions. The standard deviation was 7.5 centimeters between both clouds. It is a good number. And the coincidence percentage it was 11.8. And again, considering that the density matters, it is a very good index. Also, I applied significant change. One being that there was a significant change and zero otherwise. So the coincidence was greater in the flat areas. Of course, it was it wasn't a good coincidence in the complex and the more complex areas. The distance uncertainty increases when roughness increases and density decreases. And finally, the visual assessment when I compare the two final outputs. Further improvements. For measuring the process at full resolution of images could improve the final model, of course, because I had to downsample the images because I had hardware limitations, so I couldn't get the most of the high resolution images. Also, because of that hardware limitation, I couldn't use more descriptor types with a more high quality for feature extraction and then the matching of those features. Also, in other projects, I suggest the use of CC tags markers. Measure is optimized to recognize these markers for scaling and orientation of the model. And also even better processing images enhancement with the pre-processed of the images. For Metashape to process at full resolution 2 and to include GNSS positioning. Some of the global results is the cartography, mostly for specialists that can understand the architectonic graphic language and can extract from this kind of visualization knowledge that can be applied for preservation and conservation. But also the maps itself are like a snapshot of the current state of the heritage building. They allow to understand better the building. And also it is a measure of the quality of the documentation performed. Another output is the viewers. This is designed for specialist and non-specialist public. I used 3D Hub framework to deploy the viewers hosted this was hosted in my website. Scanning this QR you can access that and play with the point cloud or the mesh. I developed a site where users can interact with a 3D model and also see a video of different photogrammetry products such as point clouds, 3D models, and drone footage. This integration, I think, is crucial for non-specialists to understand what is documentation and why it is important. Also, yeah, how these kind of digital reconstruction, digital objects are built. Some video of the how the viewer works here. This is the model, the point cloud, the animation. Yeah. So okay. Now the visualizations. As I said before, heritage documentation can also be the foundation for heritage dissemination and promotion. So the accurate and photorealistic 3D models can also be the key to democratize culture and give access through immersive XR experiences, virtual museology, and interactive web environments. The key aspect here is on this kind of visualizations is that they address the problem of wide knowledge transfer without a technical graphic language of the viewer. So the general public can understand, can get in touch with heritage and with the documentation process without having to know all the technical terms. And lastly, I generated a printable mesh that I believe can have a remarkable effect if used in workshops, museums, or as an educational tool, not only as a platform for physical interaction, but also with potential application with VR or augmented reality applied. The image you see at the right, it is a previous project that I did 1 year ago with a huge monument in Bogota. Now, some research challenges. To pose a strategy to acquire enough quality data for the exterior and interior of the chapel to achieve a complete and similar reconstruction through two different workflows with different architectures, implementation, and philosophy, such as metashape versus mesh-run. So I wanted to know how replicable the output was comparing these two, and that required a lot of experimentation, mostly on the open source tool Mesh-run. Also, to develop a scalable photogrammetry open source workflow applicable to contexts with huge documentation need but low budgets. Then also to propose high quality visualizations and cartography with the achieved and enhanced models as input, and to find a way to successfully holistically document heritage. Additionally, to do some knowledge gap in regard to the chapel history, collecting all available data and documentation represented a challenge where the community must develop trust to cooperate. So I have to become a trustable expert for them to share with me information like in interviews on other sources. And finally, some discussion. Low cost does not mean full accessibility and often involves expert knowledge to actually be implemented. So it works like a trade-off. You want economical accessibility, you need expertise with the tools. Another aspect is, in this case, low cost also involves higher hardware demands to catch up with the proprietary software processing time. Also, once the investment is made into expert and good hardware, it's very likely that an open source and production-ready solution could be implemented as the standard for a public policy for heritage documentation and preservation. This aspect is very important because for a public heritage preservation policy, institutions needs, in my opinion, to be independent and to have their own resources to develop and to apply and to research. And also this can free resources to channel to interdisciplinary teams, to gather interdisciplinary teams, also to invest in skill acquisition, on technology, on research, and to cover more heritage. Finally, knowledge and visibility is also a protection of heritage and history. That's why communication and diffusion should be central in heritage documentation efforts. So experts in documentation, in heritage documentation, I think need also to cover the visualization and this responsibility of convey knowledge through to different kind of publics, not also expert architects, but to the general publics too. And well, I think that's all. Thank you very much.
Thank you, Santiago, for sharing your presentation. We really appreciate you taking the time to share your research with us and with the wider heritage community. I also want to thank our CIPA experts who were able to attend and provide feedback and questions during the original live event of Santiago's presentation. And so for our general audience online, if you're interested in learning more about the CIPA Emerging Professionals, please check us out on social media through the links on the screen. Or if you're interested in sharing your research or preparing for your thesis defense, please apply to our PYTDR initiative through the link at the bottom of the screen. Thank you so much.
Thank you.